Hello, good morning all of you. Today is 1st of September 2020, Tuesday, and let us do physics. We were doing the chapter electricity and magnetism. In that chapter we have covered certain portion till now. We had discussed some important terms or the quantities, charges, current, potential difference and the resistance. Now today we are going to discuss very important topic, that is Ohm's law. In the Ohm's law, we study about the relationship between the potential difference and the current. Alright? Now, if you want to have a continuous flow of current, suppose you have a conductor A and you have a conductor B. Alright, you want to have a continuous flow of current from A to B or from B to A. The most important criteria or the condition is that there should be a difference of potential. A potential difference should be maintained. If both of them have the same potential, then the current will not flow. Alright, so in order to flow the current in a conductor or between the two conductors, the most important condition or criteria is that at the end of conductor or between the two conductors, a difference of potential or potential difference has to be maintained. Now, there was a German scientist quite centuries ahead, maybe in the year 1826, a German scientist, Mr. Simon Ohm. He found in his while doing his some research work in his lab, he found a relationship between the potential difference across the end of the conductor and the current flowing through it. Suppose if this is a conductor and this is the end of the conductor, so across this end you have a potential difference, all right, and the current is flowing from one end to another. So between these two quantities, one relation is obtained, and that relation is called the Ohm's law. So first of all, the statement. What does the Ohm law state? According to the Ohm's law, the current flowing in a conductor is directly proportional to the potential difference applied across its end or across the end of a conductor, provided one condition is there, two conditions in fact, the physical conditions of the conductor and the temperature of the conductor remains constant. So then we see that the potential difference will be directly proportional to the current applied. Or we can also write like this. Let us take AB is any conductor and you have the potential difference. Suppose V is the potential difference across the end of the conductor and the current I is flowing through a conductor from A to B. So we have these two quantities, and the relation obtained according to Ohm's law is that I is directly proportional to V. That means directly proportional. In physics, you have got only two relations, either the direct proportion or inverse, indirect proportion. That means when you increase the flow of current in the conductor, the potential difference, the reading of the potential difference also increases. If the current decreases in a conductor, the potential difference across its end also decreases. So that is the direct relation. And the conditions, very important condition is that the physical conditions and the temperature of the conductor remains constant. Okay, so the temperature of the conductor remains constant. So if these physical conditions are not fulfilled or these criteria are not met, then maybe this relation may not be that, it may not come true. Okay, now let us derive Let us come to the last term that we were studying in the previous class about resistance. Resistance was the obstruction offered to the flow of the current. So now we have just learned from the Ohm's law, or we can also write this as V upon I equals to constant. This directly proportional sign is converted into equal to, and it is also replaced or added with a constant. Now this constant here is equal to the resistance of the conductor. So this constant is called equal to the resistance. So we get the formula of the resistance now from the Ohm's law. So how can we define resistance? Resistance is given by the symbol R. Okay, resistance is given by the symbol R, and the formula of the resistance is V upon I, where V is the potential difference applied across the end of the conductor. I is the current flowing through the conductor. Alright, now if in a conductor you apply or you flow 1 ampere of the current, ampere is the unit of the current, keep in mind. When a unit current is passed through the conductor, or it is flowing through the conductor, then we get, because this I becomes 1, it is a unit current. So now we can say that how do we define resistance numerically? Numerically, resistance is equal to the potential difference. It is equal to the potential difference applied across the end of the conductor when a unit current flows through it. I'll repeat one more time. You can also see this in your textbook. It is in page number 178 and page number 179. The definition of the resistance is given there. So what it is, how it is defined as: resistance is numerically equal to the potential difference applied across the end of the conductor when a unit current flows through it. Alright, so now we have completed almost all the quantities that is required in this chapter. Now, since resistance is also a measurable quantity, like in case of the current and the potential difference and the charge, all these quantities had a unit. Likewise, resistance also has a unit. So let us write down the unit of resistance. We have just learned from the formula. The formula of the resistance according to Ohm's law is V upon I, and we know that V, it is volt. We can also write volt as V, and the current is ampere, or we can write volt ampere to the power minus 1. This C, your V and V are same. Do not be confused. V is the unit of the potential difference, which is volt, and A is the unit of the current, which is ampere. So V A to the power minus 1 is the SI unit of the resistance R, and it is also named after the scientist, in order to honor the scientist who had found this relationship, Simon Ohm. So you can also call it as Ohm, O-H-M, Ohm, not Ohm, this is Ohm. Alright, so this VA, 1 VA is named as Ohm, and the symbol for the Ohm is written like this, and the symbol can be named as omega. Alright, so Ohm, SI unit of resistance is Ohm. So how do we define the Ohm? Suppose it is asked, define Ohm. So Ohm is defined as the resistance of a conductor when 1 volt of the potential difference is applied across its end and the current of 1 ampere flows through it. Alright, so omega, or we don't call it omega, omega is a symbol. Ohm is defined as the resistance of a conductor when 1 volt of the potential difference is applied across its end and 1 ampere of current flows through it. So these are the terms that we have learned so far. All right, starting with the first term, that is the charge. The symbol was Q and the unit is Coulomb, capital C. Then we came to the most important term, current. The symbol was I and the unit was ampere. Then we came to the potential difference, or the potential. In the potential, the symbol was V and the unit was volt, which is also V. Now today from the Ohm's law we came to another term, resistance. The symbol is R and the unit is, what do you call? Unit is ohm. Now there are other larger units also. You can refer to the textbook. In the larger unit you also have kilo ohm, mega ohm, etc., which is kilo is 10 to the power 3, mega is 10 to the power 6. Now there is another term, that is the conductance. Conductance is defined as the reciprocal of resistance. It is defined as the reciprocal of resistance. So we can also write like this: conductance is equals to 1 by R, the resistance. All right, the unit of the conductance is 1 upon ohm, that means ohm to the power minus 1. This is also named as Simon, or Simon. So however you pronounce it. So this is the term conductance which came out of the resistance. So if the resistance is less in a conductor or a wire, then that conductor or wire will have a high conductance because it is inversely related. Okay, now another topic in the Ohm's law is, now since Ohm's law is very easy, we have just found the formula of the Ohm's law, that is V equals to I into R. See, we have just found a relation. It was like this, starting V upon I equals to R, or you can also write V equals to I into R. We can remember this Ohm's law. The formula is very important from your numericals point of view. And it is observed that this R is the constant. R is the constant, and in order to explain this, there is a graph which we can show it. It is known as the VI graph. Let us plot the VI graph. That is, along the x-axis, let us plot the current flowing through the conductor, and along the y-axis, let us plot the potential difference that is applied across its end. Okay, so let me draw this quickly. This is the origin, and we have the current I flowing along the x-axis, and you have the potential difference that is flowing along the y-axis. Now what happens is, for any values of V, there will be a corresponding value of I. So when you do this experiment, it is not possible this year, otherwise I could have shown you one demonstration using the setup. You take one value of the port V and it will give a corresponding reading I in a device which measures the current, and that device is called the ammeter. Alright, so likewise you can take 4 or 5 values, then 2 values you will get, and when you plot it along the graph, you'll observe that you'll get a straight line. something like this. Now this straight line which is plotted, this straight line gives you the resistance of the conductor and it proves that it remains constant. The slope of this graph, the slope of the graph of the VI graph gives you the resistance. Suppose if I take any 2 point here, P and Q, and from the point I drop one perpendicular in the y-axis and I drop one perpendicular from the point in the y-axis. Let us say this is VB and this is VA, for example, the reading. And similarly you drop one perpendicular along the I1 and along the x-axis you drop another, let us say I2. Now you will find that there is a difference in the reading. This is called the change or the delta. Suppose delta V is VA minus VB, whatever it is. Okay, VA, the reading of, then obviously it will be more here than this. So this minus this reading will give you delta. Delta is a change in the value. And similarly here also you will get delta I. That means I2 minus I1. So this value you will get, and let us find the slope. The slope is this portion. The slope of this graph. The slope is between P and Q. So slope is given by delta V upon delta I, and this is nothing but the resistance. So in the VI in the VI graph, this VI graph is plotted to give the slope, and this slope will give you the resistance of the conductor, which will always be a straight line. That means in the VI graph, if you get a reading which is finally it is coming to be a straight line, that means it is obeying the Ohm's law. That means the potential difference is directly proportional to the current. The potential difference is directly proportional to the current. So these are the main thing, that this is also important topic from an exam's point of view. In the new reduced ICSE syllabus 2021, this graph is also given. So it is explained in the textbook. You can copy from the textbook as well. Now let us discuss the one more topic before we end for today's lesson. This is very, very easy. Resistors, or it is also called the conductors. Okay, the resistors, or also it is also called the conductors. We have two types of the resistors, that is ohmic resistors and non-ohmic resistors. Ohmic resistors, the key point here is it obeys the Ohm's law. Very, very easy. It obeys Ohm's law. This is obviously, it do not obey Ohm's law. Okay, it do not obey Ohm's law. Then the second point is, in the VI graph, in the ohmic resistors, there will always be a straight line, something like this. This is the ohmic resistors. If you plot the VI graph for the non-ohmic resistors, then it will not come out to be a straight line, but in fact it will be a curve. So this is ohmic, the VI graph for the ohmic resistors, VI graph for the non-ohmic resistors, because here the value of the resistance is fluctuating, it is not constant. Examples of the ohmic resistors are many. You can take any of the metallic conductors like silver, aluminum, copper, iron, etc. So all these metallic conductors are ohmic resistors. In addition to that, you also have the copper. If you take the solution, sulfate solution with the electrodes, in case of a cell in a battery, you have the electrodes or electrolytes. So that also comes under the ohmic resistors. Whereas the non-ohmic resistors, examples are many. You have LED bulbs, which we use nowadays in our homes, offices, etc. You have solar cells, and there are others like filament of a bulb. So all these are non-ohmic resistors because their resistance is not constant, it is fluctuating. Now what you need to do is, in the ohmic and the non-ohmic resistors, you please turn to your textbook in page number 181. You will find one box which gives you the difference between the ohmic resistor and non-ohmic resistor. You need to write down any three differences. I think this much for today. In the next class, we will be discussing some more topic related to this. That is, I think we will be studying electric power and energy. But now before we do that, we will solve some simple numericals. This much for today. Please do this homework that has been given to you. Thank you and have a nice day.